here with a demonstration of Wi-Fi leakage from a house. Here in front of us we have a typical small British house. It's a 2 up, 2 down, it's made of bricks, it has glass windows, and if we switch on see-through mode we can actually peek inside it and have a look at the rooms. We can see we've got partition walls and different levels. And so this will all affect the propagation throughout this property in a way that we wouldn't be able to visualize with a 2D floor plan. So in the lounge of the house we're going to place an access point. This is where most people have their APs because that's where the phone line comes in. And for this AP we're going to configure it to represent European Wi-Fi parameters. In this case Wi-Fi channel 1 down near the ground, 100 milliwatts of power, and it's just a dipole antenna. So on the phase tracing menu in CloudRF, I'm going to select high resolution, reflections high, so about 20 reflections, and density high. This actual model has 2 materials which we've defined, one for brick and everything else, and one for glass. And the reason is because glass is where most of the Wi-Fi power leaks out of a property. So we'll demonstrate this now. So I click the button, we're running this on a big GPU with about 4 million photons, so it's going to throw those photons around and reflect them and see where the coverage hits. So using this sandbox around the house we can see that most of the power is coming out the front of the property and hitting the wall over there. We're also leaking power out the side of the property because there's less obstructions between the access point and the outside versus the other side of the property. And finally at the back of the property we're coming out the windows at the back here on the ground floor. If I put on the wireframe mode we can have a peek inside this building and see that there's good Wi-Fi signal downstairs. It is a small house but there's a poor Wi-Fi signal in the back bedroom, so that's quite common for Wi-Fi because it's attenuated by all the materials, and the people up in the bedrooms are using reflected signals which are weak, and you get very patchy coverage. That's why people know in the bedroom if you move to the left or the right you can change the signal because you're experiencing multipath. So that's 2.4 gigahertz. We also have an option to use 5 gigahertz on most Wi-Fi access points, and let's go and have a look at the difference. Now if we go up to 5200 with the same hardware, same location, and repeat this calculation, the expectation is that there will be more attenuation. For bricks it's going to be about twice as much attenuation as 2.4 gigahertz. So this should box that signal in nicely, and that's exactly what we're seeing now. So the signal is boxed in, it's leaking out the window again to the front, and it's reflecting around inside the house. So we're in that back room and we're leaking out into the back garden. We're not able to be used up in the back bedroom, and there's a weak signal upstairs. So that's typical if you've ever used 5 gigahertz and thought that's not as good as 2.4 gigahertz. Well, actually it depends, and it depends on interference, which is a massive problem. So the conclusion is high frequencies are attenuated more. If you don't want your Wi-Fi to leak, use 5 gigahertz. And windows are the source of most leakage in a property, so consider placing your AP out of sight of your window near to the ground to permit local use but minimize unintended loss. That also works both ways because you're receiving less noise from your neighbor's Wi-Fi which might be interfering with your Wi-Fi. So keep it away from the windows if you can and box it in.